Hello students, welcome to our YouTube channel Diksha Karnataka. So in today's video, we will be discussing the part 2 of the mock test 3 chemistry solutions. So this video will consist of questions from 31 to 60. So if you haven't watched the first part, which consists of part 1 to 30, please do it, first watch it and then come to this video. Okay. So the question paper of this mock test is available in our WhatsApp channel. So please join the WhatsApp channel so that you can get this question paper, right? Okay, so let us go to the first question. That is question number 31. Which of the following statement is wrong regarding lanthanoids? So this question has come from your D and F block. Yeah, so we have this question from D and F block. Lanthanoids is an important topic as I discussed already. So lanthanoids, let us see all the statements and see the which is wrong among them. So are generally colorless. So we know lanthanoids are colorful compounds due to FF transition, right? So we got the answer in the first option only. This is the wrong statement, right? Now lanthanoids are predominantly ionic. What can be the reason for this? This is due to the inert pair effect. The 4f orbitals do not participate in the bonding and generally that is why lanthanoids form ionic compounds. Now third one, the ionic size of lanthanide ions decrease with the increasing atomic number. Yes, this is your lanthanide contraction, right? Then lanthanoid hydroxides are mainly basic in nature, right? So this is also a major property. So the wrong statement is option A. Now going to the next question. In the coordination compound, this is the coordination compound given to us, the oxidation state of nickel is. This is very simple question. You can see NiCN4. What will be the charge of this compound? It will be 4 minus, right? So if you take, let Ni be X, Cn is a ligand, it is a -1 ligand. So we'll get -4 is equal to -4. So we will get X equal to 0. So answer is option A, right? So we can calculate this one, simple question from your coordination compound, direct question. Next, okay, so here is a very important announcement. So all those students who are preparing for your KCET 2024, after your board exams are over, will be having a crash course on KCET, which will last for 28 days. And in this period, they will revise the whole PU1 and PU2 syllabus, right? So there will be mock test, proper revision, you will get summary notes, everything. So please enroll for this course. Detail of this course you can get in the WhatsApp channel and in the description of this video. Okay, so now let us go to our third question for today. That is question number 33. Again, this question is from coordination compound. The formula of penta aqua nitrato chromium 3 nitrate. So first of all, you can see penta aqua means there will be 5 water molecules, right? So option A we can rule out because there is 6. Option C we can rule out. Now we have option B and option D. Now so penta aqua is present here also. It is present in this option also. What is the next ligand given to us? Nitrato. Nitrato is for NO3 ligand, right? So you can see NO3 is present in option B. So the correct answer for this one will be option B, right? So again, very simple question on nomenclature. So you can see we have got many questions on coordination compounds also. It's a very high weightage chapter, so we have to prepare very thoroughly. Square planar geometry among the following. Okay, let us first find out. This is from your chemical bonding, Vesper theory. So first of all, XeF3. It will have, what is the valence electrons? We have 8 valence electrons and 3 will form. So 5 unpaired electrons will be there. We don't have any such compound here. You can neglect this option. Go to XeF4. We have 8 valence electron, right? Out of that, 4 electrons are used in bond formation. So remaining 4 electrons will be 2 lone pairs, right? So we have this structure, XeF4. That 4 remaining electrons will form a 2 lone pairs and the shape of this molecule is your square planar geometry. Let us we'll revise the other options also. XeF2. See here 8 valence electrons will be there for Xe. 2 are forming bond. So 8 minus 2 is 6. 6 electrons means 3 lone pair. So here we have 2 bond pairs and 3 lone pair. So what I will get? Xe F2, right? And we can have 3 lone pairs forming in one triangular planar. So this is your which shape? This is your linear molecule. Now coming to XeO3, 8 electrons are there, 3 are forming bonds. So oxygen will take to each oxygen will use 2 electrons. So total we will have 6 electrons are used. So how many are left? Only one lone pair is left with XeO3. Okay, so we will get this structure, pyramidal. So the correct answer here is option B, and we have revised the all other options also. So Vesper theory from chemical bonding is very, very important. That table you have to remember. Next, the number of moles of KMnO4 that will be needed to react with 1 mole of sulfite ion in an acidic solution is. This is very important question from your D block. Okay. So this question is from the properties of KMnO4. So let us first write down the reaction. What happens? We all know that KMnO4 is a very good oxidizing agent. It will oxidize others and itself it will get reduced. So what will happen? MnO4 minus will get reduced to Mn2 plus. Okay. Now you see here we'll balance this equation. There is 4, so plus 7. So reduction means it has gained 5 electrons, right? Here 4 oxygen means here it will be 4 water, and we can add here 8 H plus, right? This is the reaction for manganese. Now it will be needed to react 1 mole of sulfite ion. What is sulfite ion? SO3 2 minus will get oxidized to SO4 2 minus. What is the oxidation state of sulfur in this one? If you see, it is plus 4 and here it is plus 6, right? So oxidation has happened, loss of electrons of 2 electrons will be lost here. Okay, now you see here one water molecule, one water molecule we will add to balance the oxygen. Now that as a result of which we got 2 hydrogens, so we will add 2 H plus here, right? Now if we add both the equations, first we will check that the number of electrons should be same, right? So here 5 electron, here 2 electron. So multiply this equation with 2 and multiply this equation with 5, right? So now you can add the equation and we'll get the final equation as 2MnO4 minus, right? Then here we will get 16H plus and here we will get 10H plus. So that will become 6H plus. Plus, then we have here 5SO3 2 minus is reacting with, again we'll get 2Mn2 plus, right? And we have here, we will have 8 water molecules and we have here 5 water molecules. So 8 minus 5 will get 3 water molecules. Plus, again we have here 5 SO4 2 minus. Right. So this is the balanced equation for this reaction. Now we have the question is asking how many number of moles of KMnO4 is required to react with 1 mole of SO3 2 minus. If we see the stoichiometry of this reaction, what I can say, 5 SO3 2 minus reacts with 2 moles of KMnO4. Then 1 SO3 2 minus will react with 2 by 5 moles of KMnO4. Okay, KMnO4. So the answer here will be 2 by 5. So if we have already known this reaction, it is a very simple question. If we haven't remembered the reaction also, we can calculate it and we can just derive the relation and then find the answer. So it is an easy question but little lengthy if you haven't remembered the reaction. So now let us quickly go to the next question. Which of the following has the same size? This is again from lanthanide contraction, very, very important topic. Under the applications or the consequences of lanthanide contraction, we have this option. Zirconium and hafnium has the same size, right? This is due to lanthanide contraction. Okay, direct question, definition based, direct and easy question. Next, the ion showing a magnetic moment of 2.83 bm among the following. So first of all, when the magnetic moment is 2.83, we can easily know the number of unpaired electrons is 2, right? So we have to check in the following options which option has number of unpaired electrons as 2. So let us quickly calculate. Titanium, what is the electronic configuration of Ti3 plus? Titanium is 3d2 4s2, so titanium 3 plus will be 3d1, so n is equal to 1. Now nickel 2 plus, nickel electronic configuration is 3d8 4s2, so nickel 2 plus will be 3d8. So if we draw the 3d8 electronic configuration, we have d 5 orbitals, so 1 2 3 4 5 6 7 and 8. So we have 2 unpaired electrons here, so then magnetic moment will be 2.83 for Ni2 plus. Similarly, you can check for the other two options also. You can get the answer is Ni2 plus. Again, this is from your DNF block. Easy question, right? Okay. Next, the crystal field. Okay, the next question is from your coordination compound. Crystal fluid, what is the relation between octahedral and tetrahedral splitting? Direct relation, delta T is equal to 4 by 9 of delta O. Right, this you have to remember. It's a very fact-based question. Right, we don't have to derive anything. You have to just remember this data. Okay, next question, which of the following statements are not correct? So again, this is from your DNF block. Okay, Fe 3 minus has 5 unpaired electrons. So let us calculate what is the oxidation state of Fe here. If you see, Fe is in +3 state, right? So +3 means it is D5 configuration. So 5 unpaired electrons. This is a correct statement. We have to find not correct, right? This you have to be careful whether it is asked correct or not correct, incorrect, that you have to check. Okay, next one is a non-conductor. Yes, because it is a coordination complex, it will not dissociate, so it is a non-conductor. This is also correct. It will not produce any ions here, right? Okay, tetrahedral complexes do not show geometrical isomerism. Yes, that is also correct because all the bond lengths are same, so it will not have any geometrical isomerism. In CN group, the bonding occurs through N. No, the bonding occurs through carbon. We all know. So the incorrect statement is option D. Okay, now let's move. This is also very easy question, right? I hope all of you have got the correct answers for these questions. Let us go to the next question. Which of the following is an outer orbital complex? So for this, you should know that generally for a weak field ligand, we will get outer orbital complex. Again, chapter coordination chemistry, right? And for a strong field ligand, we generally get inner orbital complex. It's not always true. It also depends on the orbitals, vacancy, number of unpaired electrons and all. But generally this happens. So you can say FeCN6 is a strong field ligand. So it will be inner orbital. COF6 is a, F is a weak field ligand. So it can be the answer. Again, NH3 here is a strong field ligand. CN is also a strong field ligand. So answer will be option B, right? We have seen this example is given in our NCERT book. The hybridization and everything. It has sp3d2, right? So we have outer orbital used, outer d orbital is used here, so it is called outer orbital complex. Okay, simple one, fact based question. Next, the addition of a catalyst during, again this question is from chemical kinetics. Addition of a catalyst during a chemical reaction alters which of the following quantities? So we all know activation energy, right? So it changes the activation energy and makes the reaction faster. Easy fact-based question. Next. Okay, the rate for, again next question is from chemical kinetics. The rate of the first order reaction is given to us and the initial concentration is given to us. We have to find the half-life period. Okay. This is little calculation based question, but not a difficult question. So the rate of first order, what is the relation? R is equal to K into A, right? For first order reaction, we have to first find out the K value. K will be R by A. So let us substitute the value. What is R value given to us? It is 0.0069 mole liter inverse minute inverse divided by A value given is 0.2 mole liter inverse, right? So we can cancel this one, we'll get the K value. So what is my K value? 0.0069 by 0.2. But we have to find a half-life. So half-life for a first order reaction is 0.693 by K. So we'll substitute this value here. 0.693 by K will be 0.0069 by 2, right? So if you solve this, we will be getting around 20.08 something. So answer will be option B. You can check the calculation once, okay? So that is what I think we'll be getting. If any error is there or you find any difficulty, please you can comment, but I think this will be the correct answer. Okay, next question. Ethyl isocyanide. Okay, now we have entered the organic part. Okay, organic chemistry. Ethyl isocyanide. Isocyanide means NC, right? Is prepared by the reaction between what? So you can take ethyl bromide and AgCN. So you have to remember, if we take KCN, we will get cyanide, right? But if you take AgCN, we will get isocyanide. So this you have to remember. Substitution reaction. So answer will be option B. This is a direct reaction based question. Okay, next one. Okay, 1,3-bromopropane reacts with metallic zinc to form what? So this is under cyclization reaction. Again, organic chemistry. So your answer will be cyclopropane, right? So yeah, if you don't know, write down this reaction, can remember it. 1,3-dibromopropane. Okay, when you treat it with zinc, we get cyclic propane. Okay, cyclopropane is formed. Clear? Again, easy question. Which of the following is most reactive towards SN1 reaction? So we know what is the order of SN1 reaction: 3 degree, 2 degree and 1 degree. So you see, this is one primary alcohol, primary alkyl halide. This is tertiary, this is secondary, and this is also primary. So tertiary will react faster and answer will be option B, right? So this is from your haloalkanes chapter. Okay, easy one. SN1, SN2 mechanism, please remember properly. And what is the order for SN2 also let us discuss. It is 1 degree, 2 degree and 3 degree, right? Okay, next. An alkene is given to us, is treated with B2H6 in presence of H2O2. So it is hydroboration oxidation reaction. So what does B2H6 first do? You have to remember. It adds following, which rule? It adds following anti-Markovnikov's rule. Okay, this is very, very important. So what we have to do is, we have this CH3, CH double bond CH2, right? So if what is anti-Markovnikov rule? The negative part of the ion will go to the carbon having more number of hydrogen, right? So you can see this carbon is having 2 hydrogen, this carbon is having 1 hydrogen. So what will happen? OH will go to this carbon having more number of hydrogen. So my product will be CH3, CHH and CH2OH, right? So we will get a primary alcohol. Okay. So the same question, if would have been under the addition of only water in acidic medium, we would have got this product, right? So this is again a reaction based question, easy one. Acid catalyzed dehydration of tertiary butanol is faster than that of N-butanol, because tertiary butanol will produce your more stable carbocation, right? If you have seen the carbocation order, it is 3 degree, 2 degree and 1 degree, right? So because tertiary carbocation is more stable, tertiary butanol will react faster. Okay, next. Anisole on reaction with chloromethane in presence of anhydrous AlCl3. So you have remember chloromethane. So this is your Friedel-Crafts alkylation reaction. Okay. So and then anisole. What is the formula or the structure of anisole? Anisole is your OCH3 group, right? So it is a ortho para directing group because it has a lone pair electron donating group, ortho para directing. So what will happen? In one product we'll get methyl here, in another product we'll get methyl here. So my answer should be ortho methyl anisole and para methyl anisole, right? Again, very easy question from your this one is from your again organic chemistry alcohol reaction. Next question. The most acidic among the following. Okay, so this is phenol. Okay, most acidic among the following. So this question is from alcohols, phenols, and ethers chapters. Okay, so we know one thing: if electron withdrawing group is there, acidity increases. If electron donating group is there, acidity decreases. Right. So let us see. You can see para-nitrophenol is there. Nitro is a electron withdrawing group. Option D is 2,4-dinitrophenol. So there are 2 electron withdrawing groups. So acidity will be higher in this case, right? So answer for cresol structure is what? Cresol is OH with CH3 group, right? So in fact, this is a electron donating group. It will decrease the acidity. We want electron withdrawing group. In both option C and option D, we have electron withdrawing group, but in option D, we have 2 electron withdrawing groups, right? So the acidity will increase further. So answer will be option D. Okay, now next question. Which of the following compounds does not react with NaHSO3? Right, so the compound which will react with an NaHSO3 is either your aldehydes or ketones, right? And if you compare, aldehydes are more reactive than ketones. So first one will definitely react. Second one, third one, fourth one will also react because both are aldehydes. Now compared to these two, we can draw the structure and see, right? So we have a benzene ring here. C6H5CO CH3 and another compound is CH3CO CH3. Now NaHSO3 is a nucleophile which will react, right? So what is the condition? The carbonyl carbon should be more electrophilic, right, to react. So but if you see in this one, the carbonyl carbon is less electrophilic due to resonance, right? Whereas this one is more electrophilic. It has an inductive effect here also, but we know plus R is more important than or given more priority than plus I. So which one is this carbon is less electrophilic. Okay. So that is why reaction here will not happen or is difficult out of these 4 compounds. So that is why our answer will be option B. Okay. So again this question is from aldehydes and ketones. Important chapter and a high weightage chapter. Next question. Okay, so we got this ABC type question. Compound X with a molecular formula is given to us. C5H10O gives a positive 2,4-DNP test. So from this line alone, what can we conclude? That this compound is either a aldehyde or a ketone. Right, first we will note down that much. Then, but a negative tolerance test. So when it is a negative tolerance test, it cannot be aldehyde. So this C5H10O is nothing but a ketone group. So from here only we can say option B can be eliminated because pentanol, we need a ketone group. Now this can be answer, this can be answer. 2,2-dimethyl propanol. Can we draw this structure? 2,2-dimethyl propanone. Propanone is given here. Now again how we will do 2,2-dimethyl? So this compound is only wrong, so you can eliminate this option also, right? Now we are left with 2 other options. Okay, now let us go to the question. So you can see by reading the first line itself, we eliminated 2 options. Now going to the next one. On oxidation, it gives carboxylic acid with the molecular formula of C3H6O2. So this compound has undergone oxidation and the molecular formula is given to you. So it is, you can see it is a acid of 3 carbons. So you can see here option A is having propanoic acid, but option B is your butanoic acid, right? So here also we can eliminate option C because we have only 3 carbons in the product Y, but here they have given you 4 carbon. So obviously answer is option A, but let us see the next statement. So potassium salt of Y undergoes Kolb's reaction to give a hydrocarbon Z. Okay. So what is this hydrocarbon? If you see propanoic acid, right? So C3H6O2 This is the compound. Potassium salt of this one means what? It will undergo your decarboxylation, right? So we will get a radical here, CH3 CH2 dot, right? Two such radicals will react to give you CH2 CH3. So we will get the compound butane, right? You, even if you do not know the reaction, by reading the statements we can easily guess that the option is answer is option A. Okay, next let us go to the next question. Again a reaction based question. Let us see what is it. Complete the missing links X, Y and Z by making an appropriate choice. Okay. First is your addition of bromine, right? So if you see, we cannot replace this OH with bromine group, right? There's no direct reaction like that. So obviously we can eliminate this option. We can have these three options correct. Again here two bromines are replaced, so it may not be answer. Okay, let us see the next part. KCN is added, so any RX is there. If you treat it with KCN, what we will get? RCN. We know this reaction. So this one can be there. Yeah, this one can also be there. And here they have replaced H with CN, right? So this one he is eliminated here. We have to replace bromine with CN. So by reading the second part, we can eliminate these two. Okay, now let us go to the next part. So if you add water, what will happen to this one? RCN gets converted to RCOOH. So this CN will get converted to COH and this is already there and CH2 is there. Here what has happened? One carbon is missing, right? So this option is also not correct. Answer is option B, right? So this is again easy one, easy reaction based question. Okay, now let us see next question. Okay, CHCl3KOH. This question is from your amines chapter. Very important reaction, that is your carbylamine test. Carbylamine reaction. Which type of amines show this reaction? Primary amines will show this reaction, right? So this is not correct. This is secondary amine. This is primary amine. This is again secondary. This is tertiary. So answer will be option B. So this is the direct and easy question. Next one. Okay. The most basic among the following. Okay. Basicity means what? The amine, what do you mean by if it is basic? It should be able to donate electrons, right? So to donate electrons, what should be there? It should have electron density. So if we have any electron donating group, it will increase the electron density, and as a result of which donation will increase, as a result of which basicity will increase. So now let us check the option. NO2, it is an electron withdrawing group. What it will do? It will pull the electrons from NH2. So the donation or the basicity will decrease. Okay, next one. This is also an electron withdrawing group. That will also not work. CH3 is a plus I effect. It can donate electrons and can increase the electron density. Again, F is having your minus I effect, right? So answer should be option C. Electron donating group, and it has electron. Again, minus I property is more dominant in case of halogens. So it will also withdraw electrons. So our correct answer is option C. So this question we can consider from amines part, but general it also comes under basicity. Okay. Next, on oxidation with a mild oxidizing agent Br2 and water, the glucose is oxidized to. Okay, this question is from Biomolecules. The glucose structure determination, right, has 6 important reactions. So you have to learn each of these reactions carefully. What is the reactant, what is the product, and what conclusion we get, right? Every reaction has a conclusion in that part. So that we have to revise properly. So here what is there? Glucose with oxidation will give you gluconic acid, right? So this is also important question. What I'll give you a note here. Practice all the 6 reactions that is there for structure determination of glucose. That is very important. From here we'll get many questions. Okay. Please practice and revise this part thoroughly. Next question. Which of the following vitamins is water soluble? Again from Biomolecules, we know vitamin B and C are water soluble. And you can see E is not there, D is not there. So A is the name of, retinol is the name of vitamin A, and riboflavin is a name of the one of the complex of vitamin B. Okay, so this is the correct answer. Next, again from biomolecules. In fibrous proteins, polypeptide chains are held together by. So this is direct fact-based question from hydrogen bonds, right? So polypeptide chains will be held by your hydrogen bonds. We have again two types, alpha and beta, so that you have to remember. Next, Hoffman bromide. So this is again from amines chapter. Hoffman bromamide degradation reaction is to convert. So here if you remember the reaction, we have RCONH2 amide, and if you take the reagent we will get RNH2. So it is one carbon is reduced and we get from amide to amines, right? So direct reaction based question, easy one. Next, so this is the last question of this mock test. So let us see quickly. Correct acidity order of the following. Okay, this question we have to do carefully. We can see compound 1 and 2 are your alcohols, compound 3 and 4 are acids. So obviously 3 and 4 will be more acidic than 1 and 2. So if you see here, you can see 4 3 is there, 3 4 is there, but here 3 and then 2 is there, here 2 and then 3 is there. So we can eliminate this. First 3 and 4 will come. So out of 3 and 4, which one will come first? So if you see here, this in case of acidity, if we have electron donating group, it will decrease the acidity, and if we have electron withdrawing group, it will increase the acidity, right? Because of the stability of the conjugate base. So CH3 is a electron donating group, so it will decrease the acidity. So if you compare 3 and 4, 3 will be more acidic. So obviously answer is option A. So first 3 will come and then 4 will come. Okay, now but let us see the other two also. What about chlorine, the compound 2 and compound 1? So if you have remembered, chlorine has minus I effect, right? Its minus I effect is more prominent. So if we have, it may not be visible here, I'm writing chlorine here is minus I effect, right? So if minus I effect is there, it will withdraw electrons. So electron withdrawing group will increase the acidity. So the compound 2 will be more acidic than compound 1, right? So the correct option for this one is your answer A. Okay. Okay, so that's all for the today's test. I hope you all have done very well. So please post your scores in the comment section, how much you are scoring. And one more thing, join the Diksha WhatsApp channel also, so that you can get all the updates regarding the mock test solutions and when is the next mock test coming. Every detail you will get in this WhatsApp channel. So kindly join it. That will help you a lot of to boost your preparation. Okay. Fine. So if you have liked the video, now you can like, share and subscribe the channel. So all the best for your KCET exams, and I hope you will work very hard and get very, very good ranks for the exam. Thank you.